Okay, so let's start chapter 6 today on ratio and proportion. This one will be on 6.1, which is Introduction to Ratios and Rates. So what is a ratio? A ratio is a quotient of two numerical quantities or two quantities with the same physical units, such as feet over feet or meters over meters or seconds over seconds. And so they're equal, and so the rates or the units will actually cancel. And so the ways to represent a ratio, we have three. We have the fraction form, and it's 7/8, which is read the ratio of 7 to 8. We have the words form, 7 to 8, and it's read as the ratio of 7 to 8 as well. And then we have the 7:8, which is also read as the ratio of 7 to 8. So what is a rate? Well, a rate is a quotient of two measurements with different units, such as miles per hour, miles per gallon, dollars per hour. Things that in here we had the physical units canceled. Here, there are two different units. Miles would be on top, hour would be on the bottom. Now, when we're trying to compare rates, what we need to do is get to the unit rate, where the denominator is 1 in both of the rates. And so that's really the only way we can make a comparison. And then whichever one is either larger or whichever is smaller, is either the better or the worse one, or however the definition of whatever we're looking at is. And so that's how we're going to compare rates, is get to the unit rate. So the first thing we're going to do is go and convert to fractions in reduced terms. So we're going to start with two different forms. We're going to start with the the colon, and then we'll do the one with the wording. But again, they mean the same thing. So it says it's the ratio of 15 to 21. So that means we're just going to take 15 to 21. So when we do that, we divide to reduce. So they both have 3 in them. So we can divide by 3 there and get 5, divide by 3 there and get 7. And so we get 5/7 for our fraction in reduced terms. So the ratio of 15 to 21 is the same as the ratio of 5 to 7. What about this one? 77 to 21. Well, again, we're just going to put our 77 over the 121. Now we look at that and we say, well, they both have 11 factors. So 11 will go in here 7 times. 11 will go in here 11 times. And then we have 7 over 11 is our final reduced fraction. So the ratio of 77 to 121 is the same as the ratio of 7 to 11. What about when we get something not so nice, such as these mixed numbers? So when we get mixed numbers, what we really have to do is we have to convert them to improper fractions first, then we can do our ratios. Then after that, we can do several things, but we'll first go to the improper fractions. So we'll take 9 times 1 and get 9, plus 5 and get 14 over 9. And that's still 2. Now we have 3 times 1 is 3, plus 1 is 4, 4 to 3. So now we could do our ratio, and it's going to be the ratio of 14/9 to 4/3. And now we've done this several ways. We can multiply by 3/4 on top and bottom, or we can say, okay, well, let's rewrite this as a division problem. Now what we know how to do is multiply by the reciprocal, so that becomes 14/9 times 3/4. Now we can reduce. 3 goes in here once, 3 goes in here 3 times, 2 goes in here twice, 2 goes in here 7 times. Now we have 7 times 1. That's going to give us 7. 3 times 2 is 6. And so the ratio of 1 and 5/9 to 1 and 1/3 is actually the ratio of 7 to 6. Okay. So it turns out to be really nice in the end, just one nice simple fraction, and we don't have to worry about all the mixed numbers there. All right, so this one has an application where we're going to compare two rates, and basically the miles per gallon we're going to get for our trip. And so we have one vehicle traveling 202.9 miles on 13.9 gallons of gas. The second vehicle travels 221.6 miles on 11.8 gallons of gas. Find the miles per gallon for each to the 10th, and what is the best? All right, so to the 10th, that means we're going to have to take it out to 2 decimal places so we can round up to the 10th. Well, our first one, we have 202.9 over 13.8, okay? And our second one, we have 221.6 over the 11.8. And so that's, again, miles, and that's gallons, and this is miles, and this is gallons. So we want to get it so we have unit ratio, unit rates where we have one here and one here, so we have to divide. And remember, when we divide by decimals, we have to move our decimal so we have whole numbers in the denominator. And so when we do that, that's going to be what we end up with. And so we're going to actually take 138 divide, or 139 rather, because I must have wrote down the wrong number there. I had two things wrong, so I'm just going to erase it all, make it nice. That was 13.9, so that's 139. And that goes into the 2029.00. And again, we're going to go to two decimal places so we can round to the 10th. Now 139 looks like it only goes to 202 one time. So let's subtract that off. So that's a 1, that's a 9, so we have 12. And so 12 minus 9 is going to give us 3. 9 minus 3 will give us 6. Now we can bring down our 9. Now we have 139. If we go 5 times, it's going to be too much, I think. So 4 will maybe work. 9 times 4 is 36. And then that's 12, 13, 14, 15. That's 556. So we'll say 556. Subtract that off. That's a 5. That's a 12. Oh, I guess we didn't need to go all the way down here. So 9 minus 6 is 3. And then 5 and 13, that's 8. And then that one we had to borrow, so that was okay. So now we can bring that one down, 0. All right. So 139, and if we have another 139, if we have 2, let's just try times 5. See what we get here. 45. That's 15, 16, 17, 18, 19. That's 6. So that's going to be about 700. I think that's probably about as big as we're going to get, because if we get too much bigger, we're going to go over. So we subtract that. That's 12. So 10 minus 5 is 5. That was 12, and 9, and 3. And that's a 1. So that's just under. So yeah, so that's what it is. So that means this one's going to have to be a 9 probably, because we're going to bring down that next 0. And so 139 times 9, that's 81. And that's what, 27, 28, 29, 30, 31, 32, 33, 34, 35. 9, 10, 11, 12. So yeah, that's 1251. So we bring that, that's a 2, that's a 14. So it's going to be a 9, and that's going to be 9, 10, 11, 14. So 99. And so this then rounds to 14.6 miles per gallon. And so that's what it is. So it's approximate, it's not exact, it's just a rounded to number. And so that's what the first one is. Now our second one, we have 118 into 2216.00. All right, so again, 118, that's only going to go in there one time. So that's going to be 118. And so we can borrow 1 here, 8, 9, 10, 11, 110, 211. Now we bring down our 6. And 118 times maybe 8 will give us that. So that's going to be 64. 8 and 6 is 14. That's 944. If we add another 118 to that, that's 12. 4, 5, 6, and 10. So that's too much. So that's going to be an 8. So we have 944. We're subtracting those off. So 6 minus 4 is 2. Now we have to borrow all the way over here. That's 9. So we have this one. So 9 should be 9, 10, 11, 12, 13, 92. 9 minus 9 is 0. So now we bring down our 0. Now we saw that 8 was 944, so this is going to be less than 8, so it's going to be 7 probably. So it's going to be 6, that's 12, and that's 8, and so that's a 7, and that's 826. Now that's an 8, that's an 11, and that's a 4, and that's a 9, and that's a 0, and that's going to be a 7 again, and because it's less than the 944, and so that's 826. That's going to be an 8. Oh, actually, we just can borrow here, and that's a 3. And that gives us 10 minus 6 is 4, 3 minus 2 is 1, 9 minus 1 is 8. And so this one is approximately 18.8 miles per gallon. Okay. So those are their two miles per gallon for each of them rounded to the 10th. And which is best? Well, the best one is the highest miles per gallon, and so that would be the 18.8 miles per gallon. All right, what about this one? David is paid $105 for 8.5 hours of work. What is his hourly rate to the nearest penny, basically? Well, here we have 105 is how much he's paid for 8.5 hours of work. Now we want the hourly rate, so we have to divide by 8.5. And what do we do before when we divided by a decimal? Well, we moved it over 1. Well, that's where the decimal is there, so if we move it over 1, now we're taking 85 into 1050.000 because we have to go to the nearest penny. So 85 will go into 105 once, and that's 85. And we have 20 left. Bring down that. That will go in twice. That's going to give us 170. That's 30. Bring down another 0. Now 85 times maybe 3. So 15, 24, 25. And it won't be any more than that, so it's going to be a 3 there. So it's 255. Borrow 1, that's a 9. So 10 minus 5 is 5, 9 minus 5 is 4. And we bring down our next one, which is a 0. Let's say, what is 85 times 4? And actually, we could maybe do 5. Let's try 5. So 5 times 5 is 25. That's 42. Yeah, that's what we needed, 5. And so 425 minus, again, all these are subtracting off. We get a 25. Now we bring down our last one, another 0, 250. Well, 3 is going to be too big, so it's going to be back to a 2. And we said that was 170. And so that's a 0, and that's going to be an 8. And so his hourly rate to the nearest penny is, well, the 2 does not round up the 5, so it's going to be $12.35 per hour. Okay. And again, it's back to, a lot of these are going back to dividing, and so long division is what we're going to be doing on a lot of this chapter, or multiplying, and so get used to multiplying and dividing again a lot. All right, an automobile travels 220 miles in 5 hours. What we want to do is find the average rate of speed in miles per hour. All right, so 220 miles in 5 hours. And we want the miles per hour, and so that means we have to divide by 5. So we're going to take 5 into 220, and we'll see what that equals. Well, 5 times 4 gives us 20. Subtract that, we get 2. Bring down our 0, we get 20 again. That's 4. And so that's 20, 0 after we subtract it off. And so it looks like our rate is 44 miles per hour. All right, and that's all it is. So that's a pretty slow speed, going 220 miles. All right, so I'll make another video for extra examples.